the formula for the arc length using radians. So I've drawn the radius of this circle, and I'm going to draw a line somewhere else, and the angle at the center is theta. So the circumference of the circle is given by 2 pi r, and what we're after is the arc length here, and we'll call that L. Now 2 pi r is all the way around the circle, so I need to multiply my circumference by a fraction, which is this angle theta over 360. Now I can cancel some of the parts down, so the 2 and the 360 can cancel, and then if I rearrange what I've got left, I have r times theta times pi over 180. Now we already know that when theta is measured in degrees, which it is here, the angle here is in degrees, theta times pi over 180 converts the angle from degrees to radians. So the formula for the arc length L is equal to r theta, where theta is measured in radians. Okay, so in the formula, the arc length is equal to r, the radius, times theta. Now theta must be in radians. If it's not in radians, to use the formula you must convert degrees to radians first. And you can easily rearrange this formula to get these two. So in this example we're working out the angle in radians, and this is a shorthand notation for radians, this symbol here, little c, and the angle in degrees. So first of all, let's write down the formula. L is equal to r theta, and the arc length is given, so from here to here it's 5 is equal to the radius 10 times theta. So theta is equal to 5 divided by 10, so it's 0.5, so 0.5 radians. To convert the angle from radians to degrees, we use the conversion angle in radians times 180 over pi, which gives us 28.6 degrees. In the circle we have two sectors, the minor sector and the major sector. The radius is 30. So we're going to work out the arc length of the minor sector, so that's along here. Formula, substitute the values in, so we have 15 over 2, or 7.5 pi exactly. The rounded value would be 23.6. Now the arc length for the major sector, again L equals r theta, the radius is the same, but the angle theta is not. We know that the angle is 2 pi in radians all the way around, so we need to do 2 pi minus a quarter pi, and that will give us the angle here in radians. Okay, so we've got the formula, substitute the values in, and this is the angle I was talking about, 2 pi minus the one that we already know, and the exact value 105 over 2 pi. And if we add the arc length here and the arc length around the major sector, they should add up to the circumference of the circle, which is 2 pi r, and this just verifies that they're both the same as expected. Some basic circle theorems. We have a tangent, and this is the radius. The radius and tangent are always at 90 degrees to each other, so that's the angle there, that's the missing angle. In the example here, this is the center of the circle, so that's the radius, and that's a radius, and this is any point on the circumference. the angle at the circumference there, theta, and the angle here are related to each other, this angle at the center is twice the angle here. So this angle here is 2 theta. For practice, try these questions.